All right, class. So continuing with our work in section 4.6, the last two problems, what we focused on were the type where it was log base a of some argument. Let's make it a bigger x. Some expression for the argument equals log base a and some different expression for y. So the thing to note in this type is that you can rewrite logarithms into a single log on either side, and if you have a log on each side, just a single log on each side, then you can express this as x equaling y. So in the next type of examples, next couple examples we're going to look at, it's going to be a different form. Our end goal is to get it in the form log a of x equaling some constant. And we saw this type before, except we just didn't have enough skills to see other ways that we can express this single logarithm. So the goal is to get a single logarithm on one side and then the constant on the other. So let's look at solving log base 2 of x plus 2 plus log base 2 of 1 minus x equaling 1. So in this example, we have two logs on the left side and a constant on the other side. And so since it's not like a log on each side, I have to put these logs as a single log. So on this left side, I can express it as log base 2 of x plus 2 times 1 minus x equaling 1. So if you have that sum of logs with the same base, then you can multiply the arguments. So now let's just multiply those arguments even further. So we'll end up with negative x squared plus x minus 2x, so negative x and then plus 2 will equal 1. Alright, so then now we want to get rid of this logarithm, and we saw before in 4.3, I believe, that you can, whenever you have that logarithmic equation, that you can change it to an exponential. So one of the things that you can do is change to an exponential. But another thing that we can do, and we saw it in the other examples, is that you could still identify the base of the logarithm and do the base to the. And so either way, the cool thing about this is that you're still going to get to the same result. So if we change this logarithm to an exponential, what we think about as the base of the log is the base of your exponential. The logarithm is equal to the exponent, and then this is going to equal the argument. And if we did that on this problem, if we went 2 to the on both sides, 2 to the log base 2 automatically gets me my negative x squared minus x plus 2, and 2 to the 1 is 2. And so these are the same approach to the same thing. It's just a different way to do this. Doesn't matter how you do it. I hope you kind of get comfortable with one of them and can use that throughout the course. So let's go ahead and finish solving this. It is another quadratic. So let's write this down. Negative x squared minus x plus 2 is equal to 2. I'm going to go ahead and add everything over just so I can get a positive x squared term. So I'll end up with 0 equaling x squared plus x. Ooh, actually, let me slow down. Because if I subtract 2 to both sides, then I'll just have a GCF. So if I subtract 2 to both sides, I'll have negative x squared minus x equaling 0. And so what I essentially can do is factor out a negative x, and then I'd have x plus 1 equaling 0. This means that x is 0 or x is negative 1. What we want to do is check to make sure that these are both solutions. And one thing I don't want you to get in the habit of doing is, if your answer is negative, then you automatically throw it out. Always go back and just check those arguments. So our equation was log base 2 of x plus 2 plus log base 2 of 1 minus x, and is that going to equal 1 when x is 0? So we can maybe just look at this. If x is 0, log base 2 of 2 is 1 plus, if x is 0, log base 2 of 1, when we evaluate that, it's 0, and so 1 is equal to 1. That checks. When x is equal to negative 1, when we plug that in to x in our original equation, so log base 2 of negative 1 plus 2, negative 1 plus 2 is 1, and log base 2 of 1, log base 2 of 1 is going to be 0, and then we're looking at 1 minus negative 1, so you're getting log base 2 of 2, and so you're getting 0 plus 1 is 1, and so both of these answers work. Alright, I'll see you in the next video.